This is an AQA A-level chemistry question, and it's based on the nomenclature and isomerism and aromatics topics. Try each section, pausing as you go, and then when you're done, review the answers later on. So here's part A, part B, and part C. And that's a total of 8 marks. So if we start to take a look at the answers, we've got methylbenzene reacting with ethanoyl chloride in the presence of aluminium chloride. We've got the product H formed, and you're asked here for the molecular formula. So you've got to remember here that the molecular formula is the actual number of atoms of each element within a compound, as opposed to empirical, which would be the simplest ratio. So you've got what's a relatively simple question, but you've got to do it with care to avoid simple mistakes. So you simply go through. I look at the benzene ring and I can see that I've got C6H4 because I've got the 6 carbons in the ring and I've got 4 of those with H's coming off. I know I've got different things coming off the others. Now, when I add up the total carbons, that takes me to 9 because I've also got the C in the CH3, the C and the C in the CH3. Now, from there, I can work my way through the H's. So I've got 3 plus the 4, and then I've got 10 in total. So 3, 7, 10. And I have got 1 oxygen within there, which is down here. So I get C9H10O. Moving on to part B, 2 other isomers are also produced in the reaction. Draw the structure of one of the other isomers. Name the type of structural isomerism shown by these 3 products. So let's remind ourselves of what we're looking for here. This is the structure that we were given, and I've put some numbers on there so we can help to determine what difference there might be. Because within this, I've got a methyl group coming off on the 1 position, and I've actually got my carbonyl group coming off at the 4 position, my COCH3. So what I could arguably have done is put it in the 1,2 position. I could also have done it in the 1,3 position. Now, when it asks for the type of structural isomerism, there are 3 types of structural isomerism. There's chain, positional, and functional group. Well, the carbon chain is actually no different if you follow it through. The functional groups are exactly the same, but the position of the functional groups is different. For that reason, it is positional isomerism. Moving on to part C, name and outline a mechanism for the reaction of ethanoyl chloride with methylbenzene to produce H. Include an equation to show the formation of the reactive intermediate involved in the reaction. So we're moving into the proper aromatics territory here now, the aromatics topic from year 13. Once again, we've got here the diagram of the product, and I've started with the mechanism. Now, we need to remember that that first curly arrow is going to go from the electron-rich delocalized ring, very electron-rich, and it's going to the positive carbon in the COCH3 plus ion. You get 1 mark for drawing the structure here, and you can see that we're very, very clear that we've broken the ring within the benzene. We've got the positive charge, and I'm now also including this H that previously we didn't show because benzene is commonly shown as a skeletal formula. For the next mark, we're showing that the CH bond, this is why it needs to be there, the electrons are going from there back into the positive of the delocalized ring. And that will actually take you to the product that we have. So in terms of the name of the mechanism, well, it's electrophilic. The COCH3 plus with its positive charge is going to attack the very electron-rich delocalized ring. So it's electrophilic, and because we actually had an H and we've replaced it with a COCH3, that means it's substitution. So it's always worth trying to reason out the name of the mechanism rather than simply trying to learn the name. Now from there, the equation. This is the Friedel-Crafts mechanism. We have AlCl3 acting as a catalyst. We are seeing that it takes the Cl from the ethanol chloride, and we end up with AlCl4- as our secondary product. There is another step to that that's not needed in this question, whereby we can see that the AlCl4 is regenerated. The H actually takes one of the Cl's away to make HCl, and we get the AlCl3. That takes us to the end of this question. Thank you for listening.